Yeah, good afternoon. Uh, okay, so today is the lecture 5. So first, I will recall some few topics what professor has already taught. So first one is Jensen's inequality. So uh, according to the Jensen inequality, if fx is a convex function, some function, then f of expectation of x is less than equal to expectation of fx. So uh, and so then he introduced one function, that is q function. So where q function is defined as integration over from x to infinite 1 by root 2 pi e power minus t square by 2 dt. So that means suppose this is the normal distribution, 1 by root 2 pi e power minus t square by 2. So this is the normal distribution. Then qx is defined as from x to infinite. So suppose this is the x. So this integration, this is the qx. Okay, and and he has said that qx is a convex function. How, why it is a convex function? So if we take the double derivative of this qx, so that is q double dash x, if we find out, then that will be greater than equal to 0. That's why it is a convex function. Okay, so in the problem sample problem section, I will show how will you differentiate q function. Already professor has shown in his lecture. So yeah, so how will you differentiate? So and then again, q of root x. What is q of root x? Q of root x is just replace x by root x. So then it will be q of root x equal to root x to infinite 1 by root 2 pi e power minus t square by 2 dt. So this is the q of root x. Hi, can you hear me properly? So this is also a convex function. So this is also a convex function. But the condition is okay. Thank you. But the condition is here this x should be greater than equal to 0. So convex function x greater than equal to 0. For this condition, actually x greater than equal to 0. For x greater than equal to 0. So how, suppose okay, so qx equal to 1 by root 2 pi x to infinite e power minus t square by 2 dt. Now what should be the q dash x, ddx of qx? So that will be, so uh, so the derivative of upper limit, so that is 0, as it is infinite constant, so that is 0. So that minus then derivative of lower limit. Okay, so lower limit is 1, so 1 by root 2 pi. Okay, and minus then putting that value actually, so minus x square by 2. So this is the q dash x. Then what should be the q double dash x? It is uh, uh, minus 1 by root 2 pi uh, minus so uh, minus half into 2x into e power minus x square by 2, that is equal to x by root 2 pi e power minus x square by 2. So this is the convex function if x is greater than equal to 0, because this e power thing, this is greater than equal to 0. So if x, so this is greater than equal to 0 if x is greater than equal to 0. Okay, so that's why so qx is convex. And another one is q of root x, that is equal to root x to infinite 1 by root 2 pi e power minus t square by 2 dt equal to root 2 pi. So derivative of upper limit is 0, so that is, so the minus of root 2 pi, then derivative of lower limit x of half, so this is the half 1 by root x, and putting that value minus of x by 2. So this is the q. So suppose this is the function f of x that is equal to q of root x. So then this is the f dash x. Okay, now what is f double dash x? That is equal to uh, minus 1 by 2 root 2 pi, then root x to e power minus x by 2 into minus half. This is one thing, plus uh, e power minus x by 2 minus half x power minus 3 by 2, that is equal to this 1 by root x. So half common, minus half common, so 1 by 4 root 2 pi 1 by root x e power minus x by 2 plus 1 by x root x e power minus x by 2, correct? Then this is equal to 1 by 4 root 2 pi e power minus x by 2 by root x 1 by x plus 1. So this is the f double dash x, correct? So if x is greater than equal to 0, then this is also positive. So yeah, so this is the answer. So then the second one is that if fx is a convex function, then if fx is uh, convex function, then alpha into fx plus c, where alpha greater than equal to 0, so is also convex function. So fx is convex. So these are the some properties of convex function. So how to check the convexity quickly. So fx is convex function. So let us not take fx. So it's let's take some different fi of x. So where fi is the uh, ith function. So for I equals to 1, 2, dot 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 n. So for each and every I, fi of x is a convex function. So then summation of fi of x for all I, this is also a convex function. Now if f of x is convex, then so suppose this is the vector function, vector x. So then f of ax bar is a metric. So this is the affine function. Affine function. This is also convex. So affine function, and already professor has told. So still the difference between affine function and linear function is that suppose x is a uh, parameter. So y another variable y, if y is equals to alpha x, this is a linear function. And if y equals to alpha x plus some other constant b or c something, then it is called the affine function. And one more, that a max of all these functions actually, max of f1 comma fn. So these are the convex function. This is also convex function. Max is a convex function actually. Okay. And one more thing is that let fx equal to h of g of x composition. Uh, h of g of x, then fx is convex if so number one g x is convex and h of x is convex plus non-decreasing. Second one is g is concave and h of x is convex plus non-increasing. Okay. So then to another topic is that conjugate function. So conjugate function, suppose fx is not convex. So for that case also we need to find out some function that is convex actually. So convex function is all sorry conjugate function is always convex function. So suppose this f star of y, this is the convex function. So this is equal to max of with respect to all x y transpose x minus f of x. So this is the conjugate function of fx. Okay, this is a conjugate function of fx. So this f star of y, so this is always convex. Convex, even if fx is not convex. Okay, so then the next topic is quasi convexity. If this is the sub-level set, so s of t that is equals to this is the all x such that f of x f of x is less than equal to t. Okay, so if this is the sub level set with respect to t, with respect to t. So if is quasi convex, if this sub level set is convex, so if this st is convex, then we can say that fx is quasi convex. Okay, then he so one interesting thing he has uh, shown that suppose this is the x1, this is x2, and so this is the x1 x2 equal to t. Okay, let us take, so then yeah, so then this portion is x1 x2 less than equal to t, and this portion is all this portion is uh, x1 x2 greater than equal to t. Okay, so then so this portion is not convex. This is the not convex set. Why? Because if you join two lines, then suppose this if you join this line, if you join any two lines, then they not any two lines, if you join 2 points, then that line may go over, so over this set actually. So suppose, so this is the, so this is the set. Okay, so if you join suppose this line, this point and this point, so this is the line, so this line is going beyond this this set. So this set. So this is going beyond here. So here it is coming. So that's why it is a non-convex set. Okay, but here if you join any two lines, that will fall on this set only. So that's why. So this is a convex set. So this is the convex set. Okay. So this is one interesting thing. Then he introduced what is the entropy. Entropy is very useful uh, term in information theory. So what is entropy? Suppose x is a random variable. So entropy is denoted by h, and x is a random variable. Then h of x is equals to some x belongs to. So this is the this scripted x takes all those possible values of x. Okay, so this is the px. Px is the PMF, probability mass function, and this log of px. Okay, this is the definition of entropy. Let's in some uh, sample problems. The function fx equal to x cube is option A convex always. Option B is convex for x greater than equal to 0 and concave for x less than 0. Number C, the convex for x greater than equal to 0 and concave for x greater than 0. Then D is convex concave always. Okay. So so this is the question. So how to check the convexity? So the solution is very simple. So checking the convexity is just finding out the double derivative of that function. So here the function is x cube. Then so we need to find out the double derivative. So f dash x is equal to 3x square, and then f double dash x is equal to 6x. Then so we need to show that this f double dash x is greater than equal to 0. This greater than equal to 0 for which condition? See, this is not always positive actually. So this is the 6x. So suppose this is the x and this is the f double dash x. So so this is the for positive x, and for negative x this. Okay, but for positive x only, this is f double dash x is greater than 0. Okay, so this is greater than 0 for positive x. So okay, so that means this is greater than equal to 0 if x is greater than equal to 0. So that means mm, and this case for x greater less than 0, so this is x greater than is equal to 0, and for this is x less than 0. So for this case it's negative only. So that means it will be concave for this region. So for x greater than equal to 0, it is convex. So it is convex, and this is less than equal to 0 f dash x. is less than equal to 0 if x is less than equal to 0. That means it's a concave. So which condition is true here? Which option is true? So the option is uh, convex for x greater than equal to 0 and concave for x less than 0. So this second option is correct. Okay, option B is correct. Then second question is so that qx is equal to x to infinite 1 by root 2 pi e power minus t square by 2 dt. So this is a qx function. So we need to show that, find out what is q dash x and what is the, so question is what is q dash x as well as what is q double dash x. So this already I have shown how to find out. Still the solution is, so q dash x is equal to derivative of this upper, that is 0. So this is 0 minus 1 by root 2 pi into 1 derivative of x equal to 1 e power minus x square upon 2 x square by 2, that is equal to 1 by root 2 pi e power minus x square by 2 into 1 by root 2 pi e power minus x square by 2 minus half into 2x. So that is equal to minus x by root 2 pi e power minus x square by 2. Let me check once again, is it correct or not? Sorry, there was a negative sign. Negative. So this is the positive. So then the third question is the Hessian. What is the Hessian of fx is equal to x1 square plus x2 square, where this x belongs to r power 2. X is equal to x1, x2. What should be the Hessian of this thing? Okay. So that means solution is, so x is a vector, two-dimensional vector. There are two components in x. So, what is the f of x is equal to x1 square plus x2 square. So then what should be the gradient of f? Okay. So what is the gradient of f? That is equal to derivative of x1 with respect to x1. So that is equal to 1. Sorry. So that is not 1. So 2. So del of fx is, first you need to find out all the derivatives possible. So del f del x1, that is equal to 2x1, and then del f del x2 is equal to 2x2. Then del f del x2 del x1, that is equal to 0. Then del 2f del x1 del x2, that is also 0. And then del 2f del x2, that is equal to 2. Okay. And one more thing is there. So del 2f del x1 2, that is equal to 2. These are all four derivatives. So 1, 2, 3, 4. This will be helpful. So now what will be the Hessian? Hessian is, so first del f2, so this 2 0 0 2. Okay, so you can check it properly. Is correct or not. So number 4. So for a concave function, for a convex function, what is the Jensen? What should be the Jensen's inequality? So, so fx is convex. Then we can write down uh, f of expectation of x is less than equal to expectation of f of x. Okay. Now, if fx is concave, then f of minus fx is convex. Then f of minus f of expectation of x doesn't equal to expectation of minus of f of x. Then so this is the Jensen's inequality for concave function. Now, say, fifth question is what is the conjugate function of fx? So conjugate. So what is the conjugate function of fx, where fx is equal to ln of x? So so now how to find the conjugate function then? So fx is this ln of x, ln x. So then f star of y can be written as max of x. So here x and y both are scalar. As x is a scalar, so y is also scalar. So maximum with respect to x, yx minus f of x is equal to maximum with respect to x, y of yx minus ln x. Okay. Now differentiating this. So suppose this is another g of x. Okay. Now differentiating. Now max of x. So we need to find out the maximum of g of x. Okay. So how to find out? Then we need to prove that we need to show that g dash x equal to 0. It's a common thing. Okay. So then g dash x equal to, so then y minus ln x equal to 1 by x is equal to 0. then x equal to 1 by y. Okay, this is the optimal x star, optimal x. So then what should be the g of x is equal to g of 1 by y, that is equal to y into 1 by y minus ln 1 by y equal to 1 plus ln y. Correct. Now, if y is positive, so now uh, this is the f star of y. Okay, this is the f star of y. Now, so this is only finite number if y is more than zero. Okay, if y is less than zero, then this log thing will not exist. So that means so for that case, it will we can write down like this way actually. So this is infinite otherwise. Now the second question is find the next question is find q. So this solution I have. So what should be the? So this is the question. Okay. So this also I have done here before also. This one. So this is the answer. 1 by 4 root 2 pi 1 by x power 3 by 2 e power minus x is e power minus x by 2 power minus x by 2 plus 1 by 4 root 2 pi 1 by x power half e power minus x by 2 solution. Then the second, I mean, next question is what is the conjugate function of fx. Okay, so the process is same. So conjugate function is f star of y equal to max with respect to x, y transpose x minus f of x, maximum with respect to x, y transpose x minus half x transpose qx. Okay, so now suppose this is another g of x. So this is the maximum. Now what should be a gradient of g of x? Should be 0. Okay. So now what should be the gradient? That means y minus qx is 0. That means x star is equals to q inverse y. Generally, this q inverse this function, this q is invertible always. I mean, generally it is invertible for this case. So so this that's why. So x star is equals to q inverse y. Now putting that value, so g of x, where x equals to x star equals to q inverse y is equal to y transpose x. So y transpose x equal to this thing, q inverse y minus half x transpose. So half x transpose. So x is this thing, q inverse y transpose x transpose q x. Okay, that is equals to y transpose q inverse y minus half. So this is y transpose. So this q inverse is invertible. Sorry, I mean symmetric also. So this q inverse y goes to y transpose q inverse y minus half y transpose q inverse y. That is same as half y transpose q inverse y. Okay. So f star of y equals to, is the conjugate function of fx. Yeah. So that's all for today. And so I can revise again. So if you have any question, you can ask me to this. So yeah, you can ask me. After that, I will revise. Yeah, one thing I forgot to do in first class, that is introduction. So can you guys tell or write down that what are you doing? Are you in B Tech or M Tech or something, or some industry? You can tell today because today's class is short.
Sir, can you explain sixth problem?
Okay, sure. Yeah, sixth problem is finding the double derivative of q of root x. Okay, so uh, okay, so sixth problem I can take here also. So sixth problem is finding suppose x is equal to q of root x. So we need to find out f double dash x. Okay, what is this? So then we know what is q of root x. So that is equal to 1 by root 2 pi root x to infinite e power minus t square by 2 dt. Okay, so Now this is fx we are taking. Okay, so now what is the f dash x? This is equals to derivative of x with derivative of f with respect to x. So this is the integration. So now the process is that first we will differentiate this upper limit with respect to x. So this is the constant. So that is 0, 0 minus, and then we will derivative this. We will differentiate this lower limit. So that is uh, x power half. That means half x of minus half, minus half. Okay, that means 1 by root x. And then we will put this root x, this lower limit here. So then e power minus x by 2. Okay, so this is the, then 1 by root pi was there earlier. Root 2 pi. So this is the first derivative. Then second times if we do, so now we have to differentiate this again. So that will be 1 by root 2 pi, root 2. Then e power minus x by 2, and then this root x, if we differentiate 1 by root x, so that means it will be uh, minus half 1 by x power 3 by 2, and then plus 1 by root x e power minus x by 2 minus half. So this is by 2 root pi. Yeah, this was minus there. So, so that means it will be half 1 upon x power 3 by 2 e power minus x by 2 minus plus half 1 by root x e power minus x by 2. So that is, if I take 1 by 2 outside, then it will be 4 root 2 pi 1 by x 3 by 2 e power minus x by 2 plus plus 1 by root x e power minus x by 2. So this is the answer, double derivative. So now if I see and if I go there and check, is it correct? Yeah, so this thing I have written. Yeah, now it is clear.
Okay, sir. Thank you, sir.
Yeah, so I can summarize what I taught today. So then, so at first, what is the Jensen's inequality? So that is that I revised again. So this for a convex function f(x), Jensen's inequality is that f of expectation of x is less than equal to expectation of fx. Okay, and what is the q function? So q function is the so this is the standard normal distribution, the standard. distribution. So if I take some portion of this integration over some portion, so this is the qx you can write down. So suppose this is the x, so x to infinite. So this portion is called qx. Okay, and area of this portion. And so this then qx is a convex function for x greater than equal to 0, and q prime double dash x is also a convex function for x greater than equal to 0. Why? Because if so this is the q of root x. Okay, and then why qx is a convex function, so qx equals to this thing. Then if I differentiate double, if I find out the double derivative, so it is coming like this. Now this is greater than equal to 0 if x is greater than equal to 0, and q double dash for q of root x, that is also coming this thing. Okay, so this is also positive for x greater than equal to 0. So that's why uh, uh, qx and q of root x both are convex functions. And if now then the second property is that if fx is a convex function, then alpha fx plus c, this is also a convex function for alpha greater than equal to 0. And if fx is a convex function, then so some n number of convex functions are there, so then their superposition, their summations is also a convex function. Then if fx is a convex function, then if I find out the affine function, some affine function on x, that is ax plus b, f of that affine function is also a convex function, and max of some different functions. Okay, so that is also a convex function. Okay, uh, then uh, uh, let fx is equal to h of g of x. Then fx is convex if these two conditions are satisfied. One is gx is convex and fx is convex plus non-decreasing, and gx is concave, and f g and hx is convex plus non-increasing. Then what is the conjugate function? So this conjugate function and convexity check, these things are important for those assignments. So how to find out a conjugate function? So conjugate function is just defined as f star of y is equal to max with respect to x, y transpose x minus f of x. Okay, if I find out max of this portion with respect to x, uh, so that is also always convex function, even if this fx is convex or concave or not, anything else. Then what is quasi convexity? So checking quasi convexity. So f is quasi convex if this set, this is a sub level set with respect to t. So t is one another variable. So if s of t, that is equals to x, s of t is a set which is taking all the x such that f of x is less than equal to t. Okay, and professor has already so shown in his class that suppose this is the root mod x. So something curve is coming like this actually. So yeah, so the curve was coming like this. So this is so this is suppose this is this set. So this is the sub level set with respect to t. Okay. So this is the quasi convex function because this is not a convex function also. Yeah, someone is asking something. P of x equal to a is equal to p with the condition expectation of x square is less than alpha, the set of all vectors by the property. I didn't understand. I don't understand the question. Can you explain a little bit more? Yeah. So this is the quasi-convex function. Definition of quasi-convex function. Then what is the entropy? So this is the formula of entropy. So hx is equal to summation of px, where x is a random variable and this scripted x is the all set of all possible values what x can take, and that is equal. So h of x equal to summation px log of px. Then some sample problems. The first question is the function fx is equal to x cube. So we need to say that is it a convex function always or concave function always, or is there some conditions? So we showed that we need to find out the double derivative of this fx, and then here it's coming this 6x. So for x greater than equal to 0, it's a convex function. For x less than equal to 0, it's a concave function. So then, yeah, so this for these two conditions. So for in one case it is a convex, and for another case it's a concave. Then qx equal to this thing. Now we need to find out what is q dash x and q double dash x. So these already I have found out. At least here also I have found out. So this is the q double dash x. This is greater than equal to 0. For x greater than equal to 0. So that's why qx is a convex function. Then what is the Hessian of this uh, x1 square plus x2 square? So Hessian of this is coming like one identity matrix actually. Sorry, one, I mean diagonal matrix. So 2 into I2. So you may need to find out what should be the Hessian of some uh, norm of x. Okay, in your assignment maybe. So that's why that is similar to this question maybe. Okay, so not exactly similar, to do something else. So for a concave function, what is the Jensen's inequality? So for a convex function, we know Jensen inequality is this thing. Okay, and but for suppose x is a fx is a concave function, then minus of fx is a convex function. So then we can write down this thing here. Okay, this is applicable for convex function. So then we can write down this ultimately this thing. So this is the general inequality for concave function. Now what is the conjugate function of fx equal to ln x? So so conjugate function is f star of y equal to a maximum of this yx minus fx with respect to x. Actually we need to maximize this gx with respect to x. Okay, so maximize means we need to find out, we need to differentiate this gx and put that this g prime g dash x equal to 0. So then we can find out this x star. X star is the optimal x. Okay, so that is coming 1 by y. Okay, so now we need to put this 1 by y in this function. Then this is coming 1 plus ln of y. If y is greater than 0, then this ln exists. So that's why this is written like this, f star of y. Now we need to find out the double derivative of q of root x. So that is I have already found out. So that is coming this solution. Then what is the conjugate function of this half x transpose qx? So that means the process is same. We need to maximize some function g of x with respect to x and put that optimal x value in that function gx. Then we'll get conjugate function. So we have differentiated this y transpose x minus half x transpose qx. So the differentiation is this thing, and then x star equal to q inverse y. Generally, this y q is a invertible matrix. So that's why this. Then gx equal to this y transpose q inverse y. So we need to put this x star in this gx. So after that it's coming half y transpose q inverse y. So this is the conjugate function. So half x transpose qx, the conjugate function of this half x transpose qx is equal to half x transpose q inverse x. Okay, or half y transpose q inverse y. Now, okay, so here this is a repetition of question 6. Yeah, that's all for today. Probability x equal to ai equal to pi with the condition expectation x2 less than alpha. A set of all vectors pi satisfy the property of hyperplane of half space. Oh, this question. Yeah, this question, yeah, in last class maybe I have told. Or is this question is there in your assignment? Because then I can't say the answer. Then I can say in the next class the answer. because there is one constant is there. Before due date of assignment, I can't say the answer. Maybe this question I don't know. Maybe if this is common to your assignment question, then I can say the answer later. Because this question I have, this kind of questions I have dealt with in the next I mean in the last class. Yeah, I will tell the answer next class. Thank you. Yeah, if possible, you guys can introduce yourself, or you can write down in the chat also. Actually, I forgot to that do that thing in first class. Are you a graduate, undergraduate student, or postgraduate student, or something in or in industry? Okay, Tanya is a PhD scholar. Okay, nice. So you are doing PhD where? This from which college or university? Which university? Oh, okay. You are faculty also. Okay, okay. Yeah, I am also a PhD student, second year PhD student. Okay, nice. Okay, all are PhDs. Okay, model question of final exam. Okay, so I will search or I will find out the model question of final exam. I am first time T of this course actually, so I need to search whether I can find out some model question or I need to make it myself. So uh, yeah, I will try to. Yeah, I will check it later. Okay.
Okay, sir.
Okay. Fine. Thank you. Yeah, my name is Niladri. So I am a PhD student also. Okay. Thank you. Nice meeting. Yeah. Have a good weekend.